Hi guys, in this video we'll be covering hyperparathyroidism. So let's get started. Primary hyperparathyroidism. It's basically due to parathyroid adenoma and or hyperplasia. Primary means that this is a primary pathology. It's not secondary to anything else. It presents with weakness, constipation, flank pain, confusion, and in labs, you'll see hypercalcemia, hypercalciuria, increased PTH, increased ALP, and CAMP. So what is PTH? Let's just review. It has a function on the bones. It reabsorbs calcium and phosphate from your bones, right? And then it acts on the kidneys to secrete phosphate and reabsorb calcium. And then it acts through vitamin D on the GI tract, right, to increased calcium reabsorption and also phosphate reabsorption. So what happens when you have too much of PTH? Well, you'll have increased calcium from GI tract, kidneys, and your bones, right? So you'll have really high calcium secondary to increased PTH, right? And you'll have hypercalciuria. Now, why do you have hypercalciuria if you're reabsorbing the calcium in the kidneys? Well, in the kidneys, under normal circumstances, you'll be reabsorbing a certain amount up to a certain amount, and then the rest gets secreted into the urine, right? So you'll reabsorb until you reach a certain threshold, let's say 10 milliequivalents, and then the rest gets secreted out into the urine. So when you have increased PTH with increased calcium in the serum, all of that ionized calcium will be getting filtered, but not all of it is getting reabsorbed. So you end up with increased calcium in this urine. So you'll have increased urine calcium, right? And increased PTH is self-explanatory. You'll also have increased alkaline phosphatase. That's the ALP here, right? Alkaline phosphatases are a group of isoenzymes located in the outer layer of the cell membrane. They catalyze hydrolysis of organic phosphate esters present in the extracellular space. These alkaline phosphatases are present on the outside of the cellular membrane, especially in your osteoblasts, right? And remember, your PTH stimulates your osteoblast to secrete rank L. And when it does that, it also produces ALP. So you'll have osteoblasts secreting ALP and rank L, which will go on to cause maturation of your osteoclast, right? And now, why do you have increased CAMP, you ask? Well, what is the second messenger system associated with PTH? PTH binds to receptor and causes upregulation. This is going to be a G protein receptor and activation of adenyl cyclase, which is going to convert your ATP into CAMP, right? And your kidney is responsive to PTH. So when PTH comes and binds here, you'll have increased CAMP in the cells of the kidneys, which will also show up in the urine. So you'll have increased CAMP in the urine. Okay? So what about the symptoms? How come these people have constipation, flank pain, weakness, and so on? Well, increased calcium causes decreased excitability of your cells, especially your neurons and your muscles, because increased calcium makes it so the action potential threshold is increased. So they require more positive charge to enter into the cell for it to depolarize, which will show up as weakness, decreased GI motility, which will cause constipation, and flank pain is due to the fact that you have hypercalciuria. When you have increased calcium in urine, calcium can become calcium oxalate stones, which are the most common type of stones, and it can also become calcium phosphate stones, right? And it can also cause osteitis fibrosa cystica. Well, when you have increased PTH, what happens to your osteoclast? You have increased activity of osteoclasts, right? And how do osteoclasts work? Well, if you have the bone here, the osteoclast comes and sits on the bone and forms this vacuum around the bone and secretes these digestive enzymes and reabsorbs calcium and phosphate. When you have increased PTH, you'll have increased osteoclast activity, and chronically, this will result as lytic lesions or cystic lesions in your bones, and this will also cause bone pain, right? So just to review, your primary hyperparathyroidism is due to parathyroid adenoma or hyperplasia, and it will cause increased PTH, increased calcium in serum, increased urine calcium, increased ALP, and increased urine CAMP. Everything is increased, okay? So what is secondary hyperparathyroidism? Well, secondary means that it's due to something. So secondary most commonly is due to chronic kidney disease. What happens in chronic kidney disease is that your kidneys normally secrete phosphate. When your kidneys aren't working, you will not be able to secrete this phosphate, so you retain it in your serum, in your bloodstream. And what happens when you have increased phosphate in your blood? This will bind to the ionized calcium present in the blood, right? So the ionized calcium in serum will decrease. That will result in increased PTH secretion, right? And that will result in secondary hyperparathyroidism. Now, if you have a kidney transplant and you fix the kidneys, you'll fix the problem. So the hyperparathyroidism should go away. It can also result due to low vitamin D. So low vitamin D, if you have CKD, you can also have low vitamin D. If you have liver cirrhosis, you can also have low vitamin D, right? In this case, you'll be missing the 25-hydroxylase, And if you have kidney disease, you'll be missing the 1-alpha hydroxylase, both enzymes required to make active vitamin D3. So if you don't have that, you're going to have increased PTH. Okay, so what will labs show in secondary hyperparathyroidism? Well, it's most commonly due to chronic kidney disease. And in chronic kidney disease, you have decreased calcium due to increased phosphate in your blood, right? So increased phosphate binds to the calcium, right? That decreases the ionized calcium, causing increased PTH. So you'll have hyperphosphatemia, you'll have hypocalcemia, and because you have increased PTH, you'll still have increased alkaline phosphatase. Okay? And then we have another syndrome called familial hypocalciuric hypercalcemia. What happens here is that your chief cells, this is a chief cell, has calcium sensing receptors. These calcium sensing receptors sense the calcium, and if it's appropriate amounts, the calcium binds to this receptor, causing inhibition of PTH, right? If there's low calcium in the serum, the calcium will not bind to this receptor, and that will decrease the inhibition. This will decrease the inhibition on the PTH, and that will increase PTH secretion, right? So in familial hypocalciuric hypercalcemia, you'll have these calcium sensing receptors are dysfunctional or mutated, right? Because this is an inherited disease. This receptor is going to be mutated, and this is most commonly autosomal dominant. Okay? So when this receptor becomes mutated, it requires increased levels of calcium to inhibit the PTH. So if normally you required 10 milliequivalents of calcium to inhibit PTH, now you'll require 20 or 30 milliequivalents to inhibit the parathyroid hormone secretion. So what happens is that you'll have increased PTH because your calciums will always be lower than what this receptor needs to inhibit PTH. Increased PTH will cause increased calcium. And now you also have these receptors on your kidneys, right? And your kidneys normally reabsorb calcium and secrete phosphate, right? So what happens when this receptor is mutated? You will be reabsorbing a lot more calcium than you normally would. So you end up with decreased amounts of calcium in your urine, right? So that will result in hypocalciuria and hypercalcemia. Okay, so how do you differentiate this from primary? Because primary, you also have you'll have increased calcium, increased PTH, and in familial, you also have increased calcium, increased PTH. Well, you're going to do a urine test, and the urine test is going to show low calcium in urine in the familial type. and it's going to show high calcium in primary hyperthyroidism. That will be all for this video. If you like this short video, make sure to subscribe and hit the bell icon. And if you have any questions, leave a comment below. I'll be sure to answer them.